We started with the notion of deleting files yesterday, and we saw that there is no system call for deleting files. Instead, we have something known as unlink, and the basic principle was that there are references kept to the number of times a particular inode is being accessed or addressed, and we reduce that number of references to 0 we decrease the number of references by 1 when we call unlink, and when it becomes 0, it means that we can delete that. So it can be safely removed or garbage collected by the file system. We started with the discussion on hard link, which was again used to demonstrate how unlink works. So we can link two files, which means now the file 2 is in some sense pointing to it's exactly pointing to the same physical block of text in this case. The syntax was link old path name and new one. And what we saw was that, so if file was pointing to inode 3, let's say, now file 2, which is a new copy, will also point to the same inode. So that's how a link is being created. We looked at directories and files, and we said that if we want to read /etc/brc/rc, so inode number 2 contains, which is like the root inode number, will contain this list of directories in root. So we have etc, which has pointed to inode 0. In inode 0, we'll have all the corresponding files and directories in /etc. And then we have /rc, which has inode number 6, which physically points to that file, /rc. So this required approximately 6 reads. And depending on the number of levels, the number of reads will also vary. Okay, so how do we create directories? So we call mkdir command, and if we do an strace and mkdir, we can see that it's invoking a system called mkdir followed by 0777. What does 0777 mean? Any idea? Permission. So what does 777 mean?
It's typing the widest.
Okay, so what is 7? Could you, in binary, what is 7? 1, 1, 1. Good. So another way another thing I wanted to show was, whenever you create a directory, you automatically get a dot and dot dot. So current folder and the parent folder, the parent directory. And another important thing to see is that if you call it -la, you can see that for some of the directories, you see the first bit here as a D. So it means it's showing as directory. If it doesn't show D, then it's a file. But then there are other possible options also. You could have symbolic links, and some other options also are also possible. So one interesting thing, or one simple thing, which I think the people who are working on the Unix shell would have already done is, so you can look at this directory entry. You can figure out whether this is a D or a file, and you can then color accordingly. So a directory entry, which tells us about which has the mapping. The most important bits in directory entry is the mapping between a file name and an inode number. We go back. This was, in some sense, collection of directory entries, an array of directory entries. In the simplest form, you only have a mapping between the name and the corresponding inode number. But then there are a few other properties. So this says that this particular implementation says that the directory name is the size of 256. So this possibly tells you that in Unix you cannot have files greater than 256 length. Has anyone tried creating longer length files? So you just try it at your own time whether you can create larger than 256 or not. I don't know whether this still holds true for modern implementations or not. There is another important field which is D type, which is basically telling whether it's a regular file, a directory, or some other files, some other types. Okay, so how do you think ls would work on a directory? When you issue ls, what are system commands, or what would the code look like? We've looked at the directory entry. In some sense, it has to make use of directory entry. It has to parse over that. How do you think we'll do that in terms of C code? this is what a directory entry contains. And so there has to be a way of, so corresponding to read, which reads a file, there is something known as reader, which reads a directory. So we open a directory, which is corresponding analog to opening a file. You open a directory, you get a pointer, you check whether it's null or not, and you call reader on the pointer. So repeated calls give you one directory entry, and this stops when the reader returns a null. So this will basically return you all the directory entries. And now if you want to just output the corresponding inode number and the name, so you can just access those specific fields from the corresponding directory entry. And now if you want to make a more fancy version, you can, based on the D type, so from D of D type, you can also change the color. Okay, how do you think we remove a directory? What is the command for removing a directory? RM? -R. Why do we require -R?
Because you need to delete the file.
Okay, so why do you think that's a necessity?
Otherwise, the linking won't make any sense.
And you can delete everything, right? So it's sort of risky. So you should be in control. You should know that you're deleting everything. And you have the system call corresponding to that in C is rmdir. It does require that the directory should be empty. By empty, it means that it should only have dot and dot dot. And if we call it to a non-empty directory, it will simply fail. So this is also how it happens if you just invoke rm on a directory without removing all the files. So I did a bunch of tests to just illustrate this. So I created a new directory called test. I created new files, test1.txt and under test2.txt. And then I'm doing a system called trace on rf minus rf test. So what do you think will be happening if I do rf minus rf? What all system calls will be made? So if you call rm there on an empty directory, it will fail. But rm minus rf removes, and f means for force, if you don't know that. So it will forcibly remove all the files. So what all system calls do you think it will make?
First, it will delete all the files inside the.
Okay, so deleting all the file will invoke which system call? Unlink. Okay, good. And then
Then we'll call RFP.
rm. Okay. So this is a part of the text for the stress output. You call unlink for 2.txt. So 4 I think is the file descriptor. And it returns 0. And then again I don't know why they're using the same file descriptor. Maybe they closed one and then opened the other. But so the essence is that you unlink both of these, which is in some sense removing these files. You close the corresponding file descriptor, and then you also call unlink on the folder name. Now, if you're wondering why you're not calling rm this one, even I don't know the answer, but you can figure that out. Okay, now we come to the bits on permission bits. I can illustrate this through some examples. Is the font clear, everyone? Font size. Okay, first let's see the different permission bits for this corresponding, for the entities in this corresponding in this folder. So one of them shows an L. This was for symbolic links. The remaining are just to regular files. So they don't have anything in the first bit. And there is no folder in this. So if I create a folder, mkdir. So now you can see the corresponding folder has a D as the first bit. Now you see that some of these have RW and some of them have RWX. So this means that this file can be read, this means it can be written to, and this means it can be directly executed. Why is it repeating 3 times? Anyone knows that? So we have RWX, RWX, RWX. Why do we have it 3 times? Okay, so you're very close. So one is for the user, the second is for the group, and third is for the others. So you can have different groups where you can add and remove entities, and others is whatever is left. Of course, there is now a better way of doing this is through access list. Has anyone used access lists till now? So anyone who's worked on routers and stuff, you might, or networking, you might have seen access lists. So I'll now create a new file. So all of you, I hope, know that touch is used to just creating a new file. If I do an ls minus l, let me just see for this. So it shows that it has read, write for me, whereas for the group and for the others, it has only read permissions. What if I want to make this file non-writable? So I'll have to change this permission, right? I have to remove this W. So removing this W can be achieved in various ways. So one is we call chmod minus W new file.txt. So now if I look at, yeah, we put up ls minus l. Now it's remove the corresponding W which was here. So now this file would not be written to. Let's just give it a try. If I do, so if you can notice at the bottom, middle bottom, you can see that it says a new file.txt is unwritable. So try to write something, error writing, so permission denied. So you cannot write anything into this. So similarly, we can add the permission back by chmod plus W adding the write permission back. And now I can write anything into this. So there is another way to change the permissions, which is using the specific number. So we have read, write, execute. So for read, you add 4. For write, you add 2. And for execute, you add 1. So you have 3 bits. So 4 plus 2 plus 1 will give you read, write, execute. If you only have read and write, you'll have 6. And these two numbers correspond to the read, write, execute for the group and read, write, execute for the particular, for the other set of users. Okay, if I have to make this read, write, execute, what should I type in chmod? Number, read, write, execute. 7, right? So if I do 777, so now you can see that we have got read, write, execute, read, write, execute, read, write, execute. Of course, there has to be various other options you can give so that you can do it only for a particular user and not for the entire group. Sorry. Color changed because now it's become an executable. So now ls by default is also now coloring executables in a different way. Okay, so another interesting thing we can do is that, so we change the permissions to let's say 600, which means that it cannot be read by any other user. It can only be read by the user who created it. And let me now add another user. and there is a command by which we can read as a particular user. Sudo run user minus -l temp2. So let me read it as temp. So I'm now logged. I'm basically now going to execute commands as a user temp, and if I now try to read permission denied. This is because it has permissions read write only for the particular user and not for the other users.
So, can you explain those three things? One is for the user that creates the file.
Right. The other is a set of group you can create, so you can add people to a particular group. So you can create a group of, let's say, admins, or you can create a group of sudoers, or you can create some other group. And the third group is whoever is remaining, others. Okay, so now I had also created a simple hello world program in C. If I execute its, okay, so in fact I changed the permission. So so this was an executable, but it's not executing at this particular instance of time because I changed the permission bit. So if I do ch mod plus x, that prints the corresponding message supposed to be printed. Okay, so the last thing in this chapter. So we typically want to have or use many file systems when we are accessing our computer. So for example, when we insert a pen drive or thumb drive, so how are we able to read and write into that particular file or that fit? It's exposed as just a regular folder or a directory on your laptop, right? On Linux at least. On Windows, I'm not sure how this happens. Similarly, I have named it. So we also saw in one of the labs /proc, if you remember. So /proc is known as proc file system. You also have TMFS, which is a temp file system. But all of this to us looks like a single file system, right? So that is the beauty of Linux, that you can mount and unmount different file systems. And if you run mount, so you can see that maybe this is the first partition, and on this you have installed Linux, and this comes out as ext4. You can have SDB1, which could be backups, so you store all your backups on this particular location. And you can have NFS, which is a network file system. So you can create such complex hierarchies. So let's say this is mapped to the first partition. This is maybe mapped to your pen drive. Like this is physically housed in your pen drive, but your pen drive could be like pointing to /backups. So all of them are mounted in such a way that you can create complex, very useful hierarchies. This is a small video which I wanted to show.
One of the key differences between Linux and other operating systems like Windows is the fact that you need to mount a file system on Linux before you can use it. Now, this is one of those things that really confuses new Linux system administrators. Understand that on Linux, you have to mount hard disk partitions, DVDs, USB drives, etc. before you can actually use them. Now, the good news is the process of mounting a file system on Linux is really pretty easy. It's done using the mount command. The mount utility mounts the file system that's already been created on a partition or on an optical disk or on a flash drive into an existing directory within the Linux file system. That way, when you switch into that directory, what you're actually doing is switching to the file system on that storage device. To use the mount command, you enter mount, and then you use the -T option to specify which file system you want to use. Then you point to the partition that you want to mount, and remember that this has to match what is configured on this. You can't just use whatever file system you want. If I've created an ext4 file system on SDB1, then that's the type of file system I have to specify with the mount command. Then after the device file that we're mounting, we specify where in the file system we want to mount it at. In this case, I'm mounting it in a directory called /mount/shared. You can see that in my /mnt directory, I already have a directory named shared. That way, when I switch to the shared directory, what I'm really doing is switching to this partition, the first partition on the second hard disk in the system. Now, here's a little tip. There may be times when you need to mount a storage device, say a flash drive, and because it's a flash drive, you're not the one that actually partitioned and formatted it, and so you may not know what file system it uses. In these situations, you can use the -A option instead of the -T option. And if you use -A, you don't have to specify a file system type. You still specify the device file name and the directory you want to mount it in. Using the -A option will cause the mount command to try to mount whatever partition you've specified using all supported file system types until one actually works. And as soon as that's done, it goes ahead and completes the mounting operation. Now be aware that on most distributions, the /mnt directory is the default directory that's used for mounting both local and remote file systems. When I say local, I'm talking about locally connected devices such as a USB drive or an optical disk, while a remote file system is one that's being accessed on another computer over a network connection. Now, you don't have to use /mnt to mount a file system if you don't want to. You can mount a partition into any directory in the Linux file system that you want. However, by convention, /mnt is used by default for this purpose. Now, on most distributions, /mnt is used to mount not only partitions on a hard drive, but also external flash storage devices like a USB drive. It's also used for mounting optical devices such as a DVD. However, be aware that some distributions will kind of split things up, and they will use /mnt for mounting partitions on hard drives, and they will use the /media directory for mounting removable media like an optical disk or a USB flash drive. Now be aware that there are other options you can use with the mount command that we haven't covered here. Go ahead and look at the man page for mount. You can see a complete listing of all the available options. For example, you can use the -O option to specify mounting options that are used as that device is mounted into the file system. A good example would be -ORO, which mounts whatever device you specify into the directory you specify, but mounts it read-only. So you can read information from it, but you can't write information to it. Now, after mounting the partition, you can then use the mount command with no options and no parameters to simply view all of the mounted file systems. This is a very useful command that you should remember. You can then look through the output to verify that the device you specified is actually mounted in the directory you specified. In this case, we mounted /dev/sdb1 in the /mnt/shared directory using the ext4 file system. Now, you need to be familiar with this file right here, /etc/mtab. This is an important file. Understand that whenever you mount or unmount a device in the Linux file system, this file gets updated. Therefore, it always contains the most current list of currently mounted file systems. And it is just a text file, therefore you can view it using a standard text viewing utility like cat or less or more. And by doing so, you can see a list of mounted file systems. And here you can see that we have SDB1 mounted in the directory we specified with the file system we specified. In addition to the /etc/mtab file, you can also view the contents of this file to view information about mounted file systems, /proc/mounts. And again, it's just a text file, so you can use cat, less, or more, whatever it is you want to use to view it. And again, we see the partition that we mounted in this directory using the ext4 file system. Now, in addition to mounting a file system, you can also unmount a file system if you need to. And this is done using the umount command. Now, as soon as
So I want to show you an interesting application of the same. So this is my virtual machine, and I ended up mounting. So if I go to desktop. So this looks like a drive, right? Like a pen drive which has been mounted on. So this is in fact coming from the host machine. This is coming from my classroom from my website folder, and this has been mounted here. So this is an example of where you are sharing a file system over the network. And this I did as an auto mount. So every time my virtual machine boots up, it can now it directly bounces up. Now, if I make any changes in this, will they get reflected in my main storage or not? Yes or no? So I've had both experiences. Sometimes it didn't work. But this is just showing you the power of mounting.